Work? Well, yes. A scientist would call this work. It's the output of this particular machine. Once again. So, why doesn't the horn blow? Because there's no input of energy. Energy is needed to make something move, to do work. In this case, the energy to start the machine is called mechanical energy. And when we have an input of energy, we can do work. Of course, there are lots of ways to use mechanical energy that are even more useful than our tooting machine. The work here is pushing air mechanically with the blades of a fan. But what gives the fan its mechanical energy? It's transferred from another kind of energy. All things that happen are energy transfers. A raindrop falling. The wind blowing. A plant growing in the sunlight. An inchworm crawling on a leaf. A spacecraft blasting off. A girl scratching her back. Before anything can happen, some kind of energy has to go in to make another form of energy come out. The form of energy that goes in is called the input energy. The form that comes out is the output energy. By now, you've probably guessed that there must be a number of kinds of energy. Liquid fuel, for instance, contains chemical energy. When it burns with explosive force in a cylinder, some of the energy is transferred to mechanical energy to make propellers or wheels go around. Chemical energy input, mechanical energy output. A lantern, chemical energy input. What kind of output? Food, chemical energy input. What kind of output? A gas stove, chemical energy input. Output? Well, it's mostly heat, of course. And heat is another important kind of energy that we can make work for us by using machines such as a turbine. A toy turbine can't do much useful work. But in a power plant, huge steam-driven turbines run generators that produce most of our electricity. And this brings up another form. Electrical energy. When you input electrical energy, think of all the forms of output you can get. Also, you can store electrical energy in batteries and have fun with it.
Ready?
Then there's light energy. You probably think of light as being most useful to see by, a form of output energy.
Put it down, let's try it.
When you think about it, Light doesn't seem to be useful as input energy, except maybe to run a toy car with a photoelectric cell. Right?
Okay, here it goes.
Wrong. Without sunlight to make plants grow, all your troubles would be over because you wouldn't be alive. Sunlight input. Food, which is stored chemical energy. Output. Very useful. Another form of energy is the energy in the nucleus of the atom. Because nuclear force is so hard to control, we've found only limited uses for it so far, mostly in producing nuclear energy in power plants. In a nuclear reactor, the fuel is uranium rather than coal or oil, but the purpose is the same, to provide heat to boil water. The steam runs a turbine to make electricity. That's a lot of information to throw at you all at once. Can you remember the different kinds of energy that we've talked about?
Well, sure. There's mechanical energy,
Chemical energy,
heat energy,
electrical energy,
light energy.
and nuclear energy.
Ah, thank you. Thank you very much. And now, moving right along. So far, we've talked quite a bit about input and output of energy. There's something else to know. Does this give you a clue to the relation of input to output? We can get more input by making the inclined plane steeper. The output is greater. Lesson. The input is always equal to the output. The input and output are mechanical energy, but there is also a small amount of heat energy caused by friction. If we could measure the input of mechanical energy, we'd find that it exactly equaled the output of mechanical energy plus the heat energy. There is no energy lost in this transfer. The same principle applies in an automobile engine. The amount of chemical energy that goes into the tank equals a certain amount of mechanical energy, a lot of heat energy, a little light energy, and some energy that goes into forming other chemical compounds. A lot of the energy is wasted, not lost, just not useful. It's not always easy to recognize the forms of energy. For instance, the energy transfers that happen during the process of bringing light to your house form a long chain. This is one of the ways it might happen. Heat energy from the sun causes water to turn into vapor. The vapor rises and forms into clouds. When the clouds become cold, they turn back into water. The force of gravity pulls the water downhill, and some of it is collected behind a dam, where the energy of falling water can be transferred into electrical energy. Let's use water power to make our own electrical energy, where we can see it.
Turn it on.
This isn't a very sophisticated turbine, but the principle is the same as a real one. It turns an electric generator. The mechanical energy of water is transferred to mechanical energy here, which turns a coil between two magnets here. This transfers the mechanical energy to electrical energy. Electrical energy is transferred to light energy. And the light energy is reflected off the page and into your eyes. And there is an energy transfer as the light falls on the back of your eyeballs and flashes along nerves into your brain. In the cells of your body, there are billions of transfers of energy each second. In the universe, The exchange of energy from one form to another is beyond counting. There is energy transferred in all things that happen. Nothing is lost.